Welcome back with another video on TryHackMe.com. This is Zahin Nazir and we are doing Linux Fundamental Part 2. It is part of Cybersecurity 101. We are very late on doing this part as the official Try Win Me is over. Apologies for that. I was not able to do it because of my family commitment. As you can see, the day is 00. But let's see if we will still get the tickets once we complete this room. So Linux Fundamental Part 2, it will take hardly 20 minutes, maybe more than 20 minutes. Continuing your learning Linux journey with Part 2, you will be learning how to log into a Linux machine using SSH, how to advance your commands, file system interaction. Awesome. And this is information kind of room. So I already started my attack box as well as the machine. As you can see, the target machine is also available, which is in the task 2. So let's start from this task 1, introduction. So here is our penguin. She is saying hi. So we are hiing her back. Welcome to the second part of the reworked Linux Fundamental series. We will be applying our knowledge from the first installation in this series. So I highly recommend you completing the data room. We already done so. Before proceeding further, in part 2, we will be ditching the in-browser functionality and help you get started in what is a fundamental skill is in being able to log into and control the terminals of remote machines. Okay, not only this, but the room will also have you unlocking the potential of your first few commands by introducing you to using flags and arguments in the commands, advancing your knowledge of the file system to perform some more useful commands such as copying and moving files, discovering how access to files and folders is managed and how we can determine our access, running your first few scripts and executable. Awesome. Let's proceed. We'll click on continue. This is a correct answer. I'm on streak 2, 88 streaks to go. Let's see how we'll do that. Okay, in the task 2, accessing your Linux machine using SSH. So before we continue, so this is our terminal. We will be doing it from terminal. In-browser functionality was using the Linux Fundamentals Part 1 to get you directly connected to your first ever Linux machine without any hassle. That is very correct. In fact, the in-browser functionality uses the exact same protocol that we are going to be using today. This protocol is called Secure Shell or SSH for short, and is the common means of connecting to and interacting with the command line of a remote Linux machine. We'll be deploying 2 machines in this room. Your Linux machine, which is we already deployed, and this is the IP address of that machine. The TryHackMe attack box, which is over to the right side. Okay, what is SSH and how does it work? Secure Shell or SSH simply is a protocol between devices in an encrypted form. Using cryptography, any input we send in a human readable format is encrypted for traveling over a network, where it is then unencrypted once it reaches the remote machine, such as in the diagram below. So the cryptography, they just mention it is just a cryptography. At the end of the day, it is Diffie-Hellman kind of algorithm with using the certificates. Okay, and these certificates have public and private keys, and there is an algorithm. We call it log algorithm to define some values to determine which prime number and certain values will be used by my computer, and which certain values of prime number and the other parameters will be used by the Linux server. So this happens using Diffie-Hellman algorithm or the protocol. Okay, this will not make sense right now, but maybe in the cryptographic section we will be able to see in more detail. Okay, so here we go. My computer is sending hello world message to Linux server over the internet, and as you can see, we encrypted the message before we send it to the internet. And now once the message is reached to the Linux server, it was able to decrypt the message, and the original message hello world is there. Okay, You can learn about the various types of encryption on a TryHackMe room, but for now we only need to understand that SSH allows us to remotely execute commands on another device remotely. Okay, remotely. They already put remotely, so remove this one. Any data sent between the devices is encrypted when it is sent over a network such as internet. Yeah, sure. Deploying your Linux machine, we already done so. So these are the instructions how you can do it. We already completed this one. Okay, using SSH to log into your Linux machine, the syntax to use SSH is very simple. We only need to provide two things: the IP address of the remote machine, which is this one, 10.10.11.2, correct credentials to a valid account to log in with on the remote machine. That means we need to have a credentials of an account which exists on that target machine that we are trying to log into. Okay, so in this case we call it remote machine or a target machine. Okay, whichever name you prefer. And that's it. Let's see how we're gonna do this. For this room, we will be logging in as TryHackMe. So this is the username and whose password is also TryHackMe. So this is the password without the quotation marks, of course, marks. Let's use the IP address of the machine displayed in the card at the top of the room as the IP address, and this user to construct a command to log in to the remote machine using SSH. The command to do so is SSH. So we just type SSH space and then the username of the account. So in this case it is TryHackMe and then add and then the IP address 10.10.11.2. Okay, we have done so. So this is the command they have placed it here. Replacing the IP address with the IP address for your Linux target machine. Once executed, we will then be asked to trust the host and then provide a password for the TryHackMe account, which is also TryHackMe. So let's do that. I will just press enter and it is saying, are you sure you want to continue? I will say yes. Why? Or the full word yes. And it is asking for password. So I'm typing the password now. But the password will not be displayed here, or even the typing that you are doing will not be displayed here. I will just press enter after typing the correct password, and as you can see, I'm logged in as TryHackMe user, and the Linux host name or the DNS name is Linux2. All right, let's say who am I, and what is the current directory? All right. What is the IP address? So this is the IP address on the Ethernet 0. This is local loop, which is on QLAN, and as you can see, local loop is available on 127.0.0.1. So moving on with other commands. Now that we are connected, any commands that we execute will now execute on the remote machine, not our own. Note, when you type a password into a SSH login prompt, there is no visible feedback. Yes, that is true. You will not be able to see any text or symbols appear as you type the password. It is still working. However, you just type the password and press enter to log in. This is very useful hint for newbies. I've logged into the Linux Fundamental Part 2 machine using SSH. Completed. Awesome. So we are 9 minutes into the video and we are on just task 2. Okay, let's continue with task 3. Okay, finally something good. Introduction to flags and switches. A majority of commands allows for arguments to be provided. These arguments are identified by a hyphen and a certain keyword known as flags or switches. We will later discuss how we can identify what commands allows for arguments to be provided and understanding what these do exactly. When using a command, unless otherwise specified, it will perform its default behavior. For example, ls lists the contents of the working directory. However, hidden files are not shown. Sure, we can use flags and switches to extend the behavior of the command. Using ls, example ls inform us that there is only one folder named folder1. Let's try that. Yeah, we have my folder here and some other files unknown and my file are unimportant, highlighted in the screenshot below. Okay, so for us we have my folder. However, after using the a command short for all, we now suddenly have an output with a few more files, folders such as hidden folder. Okay, let's try that. Okay, we have dot, we have double dot, we have bash logout, bash rc, cache profile, and some others. All right, commands that accept these will also have a double hyphen and help option. This option will list the possible options that the command accepts, provide a brief description and example of how to use it. Let's do that. In previous room we discussed the man pages, right? So man ls will give you the same thing as help, I think. Okay, so we have a lot of things here. So small a does mean something else and capital A does mean something else. Do not ignore entries starting with dot. Do not list implied dot and double dot. Okay, and there are a lot of other commands as well. Okay, just take a look and move on. You can pause the video to see all of this, or you can try it at your own end. Let's continue. This option is in fact a formatted output of that is called the man page, short for manual, which contains documentation for Linux command and application. Let's try the man ls. So this will basically go inside the man pages itself. But if you say ls and then help, it will basically print out everything for you. Okay, so you can scroll it and up and down in the terminal itself. Okay, manual page. The manual pages are a great source of information for both system commands and application, available on both a Linux machine, which is accessible on the machine itself, and online. To access this documentation, we can use the man command and then provide the command we want to read the documentation for. Using our ls example, we would use man ls to view the manual pages for ls, like so. Okay, we have done so already. Export the manual page for the ls command, we have done so. What directional arrow key would we use to navigate down the manual page? Down. Yeah, okay. This is a very strange question to ask. What flag would you use to display the output in a human readable form? Human readable. So this is what we're gonna use. Human readable. Or you can just also do a search here, human, and it will directly highlight the line that we are looking for. Okay, so you just don't need to manually scan the file itself. Okay, you can just use the find to do that in case you are using a help menu. Right, task 4, file system interaction continued. Okay, we covered some of the most fundamental commands that interacted with the file system when interacting with the file system on the Linux machine. For example, we covered how to list and find the contents of the folder using ls and find navigating the file system using cd. In this task, we are going to learn some more commands for interacting with the file system to allow us to create files folder, move files and folder, read files and folder. Okay, let's do that. More specifically, the following commands. Okay, so we have a touch to create a file, make directory, create a folder. So cp is copy, copy a file or folder. MV is the move command. Just two character commands. Move a file or folder. RM is remove command. Remove a file or folder. File determines the type of a file. Okay, so let's do that. So let's say I will do the ls and then try my file. So this is a ASCII text file here. Okay, pro tip: similar to using cat, we can provide full file path directory for all of these commands. Okay, getting files and folder, touch and make dir. Creating files and folders on the Linux is a simple process. First, we will cover creating a file. The touch command takes exactly one argument. Double hyphen, the name we want to give the file we create. For example, we can create the file node by using the touch node. Why they put the double hyphen here? Okay. It's worth noting that touch simply creates a blank file. You would need to use commands like echo or text editors such as nano to add text, add content to the blank file. Okay, so if you just say touch node without extension, then there is a node. If we say nano node, this is a simple node. What if I don't save it? Okay, no. What if I just say what is the, okay, so it is empty. As you can see, node empty, so the file type is not there. Okay, so what we do is we do nano node, and this is a simple node. Let's save this, Control O and Control X to exit, and let's run the same command again. As you can see now, this file does have ASCII text. Okay, awesome. This is similar process for making a folder. We just involve using the makedir command and again providing the name that we want to assign the directory. For example, creating the directory my directory using mkdir my directory. Okay, let's do that. So mkdir. So since we already have access to this particular home directory, so we don't need to use sudo because we already have access to create whatever we want in this particular directory. Sometime in some of the folders, you will not be able to create any directory because you would require either root access or the sudo access or the sudo permissions on that particular directory. All right. So far as it will be just piece of cake without going further. I just created the directory because I do have access to create the directories in this particular current directory, which is home try hack me. All right, so I created the directory my directory. As you can see, the color of the directory is different than the files. Okay, so I did the ls and we can see all of these files. Excuse me. Okay, removing the files and folder RM. RM is extraordinary out of the commands that we have covered so far. You can simply remove files by using RM. However, you need to provide the OR switch alongside the name of the directory you wish to remove. Okay, let's do that. RM node, and without asking anything, it will just remove it. Okay, there is no warning at all. So let's remove the directory as well. So this is the my directory, right? So this is what I want to remove, and it is gone. Awesome. Copying and moving files and folders, CP and MV. Copying and moving files is an important functionality on a Linux machine. Starting with CP, this command takes two arguments: the name of the existing file, the name we wish to assign to the new file when copying. That means also the path itself where we want to copy the file itself, along with the name of the file. Okay. CP copies the entire contents of the existing file into the new file. In the screenshot below, we are copying the node to the node 2. Okay, so let's create a file first, node, and then as you can see, there is a file. Let's put something in that file. All right, something, save and exit ls. All right, so let's copy node to node 2 as well in the same directory. All right, so if we do cat node 2, it will give us something here. All right, good. All right, moving a file takes 2 arguments, just like the cp command. However, rather than copying and or creating a new file, move will merge or modify the second file that we provide as an argument. Not only you can use mv to move a file to a new folder, but you can also use mv to rename a file or folder. For example, in the screenshot below, we are renaming the file node2 to be named node3, and node3 will now have the contents of node2. Okay, let's do that. So we are moving a file which will have this new name. That means we are renaming it. So if we do cat node3, we have something here which is missing e inside. It was the same thing that I had typed before. Okay, so and nothing has changed. All right, determining file type. What is often misleading and often catches people out is making assumptions from files as to what their purpose or contain contents may be. Files usually have what's known as an extension to make this easier. For example, the text files usually have an extension of .text, but this is not necessary. All right, so for the files we have used in our examples have not had an extension. Without knowing the contents of why the file is there, we don't really know its purpose. Enter the file command. This command takes 1 argument. For example, we will use file to confirm whether or not the node file is an example, is our file in our example is indeed a text file, like so. File and then the node. Okay, file and node, it is basically text file. If there is a let's go with the important. It is also a text file. What about the file unknown? It is also a text file. So all of these are text files. How would you create the file name named new node? Touch new node. Awesome. On the deployed machine, what is the file type of unknown one? इसकी ASCII text. We have coincidentally already have done this. How would we move the file my file to a directory folder, a directory my folder? Okay, so we need to move mv and then the file itself and then directory my folder, right? So let's try mv my file and then the folder is, I think, my folder and then this one. Yeah, correct. What are the contents of this file? Which file? Okay, ls my folder. We don't have anything here. What are the contents of this file? Which file, man? My file. Okay, my file. Okay. So my file, cat my file. This is the contents. Put it here. Submit. Awesome. Continue to applying your knowledge and practice command for this task. We have done so. Alright. Permissions 101. This is important. Alright. As you would have already found out by now, certain users cannot access certain files or folders. We have previously explored some commands that can be used to determine what access we have and where it leads us. In our previous task, we learned how to extend the use of the commands through flags and switches. Take for example the ls command, which lists the contents of the current directory. When using the this hyphen and L switch, we can see 10 columns such as in the screenshot below. However, we are only interested in the first 3 columns. Okay, so let's try LH. We are interested in the first 3 columns, so 1, 2, 3. All right. Although intimidating, these 3 columns are very important in determining certain characteristics of a file or folder, whether or not we have access to it. A file or folder can have a couple of characteristics that determine both what actions are allowed and what user or group has the ability to perform the given action, such as the following: read, write, and execute. Using SU to switch to user 2. Okay, let's do that. SU user 2. It will ask for the password. Let's use the PAM file issue. What is the password? Okay, let's use the user 2 as password as well. Yeah. So user 2 has the password of user 2. Alright. Let's use this cmnatic.pam file in our initial screenshot at the top of this task. It has the hyphen indicator highlighting that it is a file, and then rw followed after. Okay. ls.lh. Yes, so R is read and W is write. Okay, so this hyphen mean, this minus sign mean we are missing some permission here, or something is missing here. Okay. Okay, so the pm file, cmnatic.pem file, it's not there. Okay. I don't know which file they are referring to, but this is what they are referring, RW. Okay. Briefly, the differences between users and groups. The great thing about Linux is that permissions can be so granular that whilst a user technically owns a file, if the permissions have been set, then a group of users can also have either the same or a different set of permissions to exact same file without affecting the file owner itself. Awesome. Let's put this into a real-world context. The system user that runs a web server must have permission to read and write files for an effective web application. However, companies such as web hosting companies will have to want to allow their customer to upload their own files for their website without being the web server system user, compromising the security of each other customer. We will learn the commands necessary to switch between users below. Switching between users. Switching between users on a Linux install is easy work thanks to the SU command, unless you are the root user or using the root permissions through sudo. Then you are required to know 2 things to facilitate this transition of the user account: the user we wish to switch to and the user's password. The SU command takes a couple of switches that may be relevant to you. For example, executing command once you logged in or specify a specific shell to use. I encourage you to read the man page for SU to find out more. However, I will cover the -L or -L or double minus login switch. The simple by providing the -L switch to SU, you start a shell that is much more similar to the actual user logging into the system. We inherit a lot more properties of the new user, environment variables, and the likes. Okay, so we already done so. For example, using the SU to switch to the user 2, a new session drops us into a previous user home directory. So let's go to the okay, yes. So as you can see right now, we are in home try hack me pwd, but we want to go to the home directory of user 2. So how we can do that? Let's switch back to the try hack me. And let's go back with L user 2. And if I do pwd, we are in the home directory of user 2. Awesome. Where now for using -L or -L, our new session has dropped us into the home directory of the user automatically. Awesome. On the deployed machine, who is the owner of the important? Who is the owner of the important? So we need to go back to the try hack me, or no, we can just go to the cd home try hack me. Just do the ls -lh. So who is the owner of important? User 2. So this is the owner, user 2, and I think this is the group. What would the command be to switch to the user 2? Su user 2. All right. Now switch to the user 2 using the password user 2. Okay. Su user 2 user 2. Okay. Output the contents of the important. What is the flag? Get important. So this is our flag. Awesome. Moving to task 6, we are 30 minutes into the video. They need to update that. They considerable take much time to do all of these steps. Did not we complete the permission 101? Okay, yes. We are missing one thing here. Moving on to the task 6. Common directories. Okay. So /etc. This root directory is one of the most important root directories on your system. The etc folder, short for etc, is a common place location to store system files that are used by your operating system. For example, the sudoer file highlighted in the screenshot below contains a list of users and groups that have permission to run sudo or a set of commands at the root user. Okay. Also highlighted below are the password and the shadow files. These two files are special for Linux as they show how your system stores the passwords for each user in encrypted formatting called SHA-512. Okay, so let's go to the cd etc. Okay, and then ls. Oh wow, there are a lot of things here. So here are the sudoers. So let's do the cad sudoers. We don't have permissions to do so. Okay. So all right, let's move forward. Var /var directory with var being short for variable data is one of the main root folders found on a Linux install. This folder stores data that is frequently accessed or written by services or applications running on the system. For example, log files from running services and the application are written here, var log. Let's do that. Var ls, we have logs folder here, cd log, and we have all kind of logs here. All right, we have done so. So it's, okay, or other data that is not necessarily associated with a specific user, databases, and the like. As you can see, we have gz file, wtemp, and many other things. All right, root, unlike the home directory, the /root folder is actually the home for the root system user. There isn't anything more to this folder other than just understanding that this is the home directory for the root user. But it is worth a mention as the logical presumption is that this user would have their data in a directory such as home root by default. Okay, so let's go to the cd root. We cannot do that. What about if we go to this home and then root? There is no such directory here. I mean, there is no root folder user. Apologies. Temp. Okay, so let's move on to the temp folder. Let's see. Oh, we have a lot of files here. This is a unique root directory found on a Linux installs, short for temporary. The temp directory is volatile and is used to store data that is only needed to be accessed once or twice, similar to the memory on your computer. Once the computer is restarted, the content of this folder are cleared out. What's useful for us is pen testing is that any user can write to this folder by default. This is very useful permission that we have. Any user can write anything in this temp folder. That means if we need to upload some file on a system with a user which don't have any access, we can just upload to the temp folder, okay, and then do all kind of stuff, shady stuff from there. Okay, meaning once we have access to a machine, it serves as a good place to store things like our enumeration scripts, ls, to do trash.txt and other things. Okay, so we have seen that systemd private some services data is here, Apache 2, and then we have login d, and then we have resolved services, which is I think a DNS service, and then we have time sync service as well. All right, readme, we have done so. What is the directory part that would we expect logs to be stored in? Var logs, log without s. What root directory is similar to how RAM on a computer works? Temp, of course. Name the home directory of the root folder. Root. Because we don't have access to root. We don't have permissions to do so. Alright. Now apply your learning and navigate through these directories on the deployed Linux machine. We have done so already. Moving on. Conclusions and summary. Nice work. This room was quite theory heavy and covered quite a range of fundamentals in getting you familiar with the Linux. To quickly recap, this room taught you or us how to connect to a Linux machine remotely using SSH. We have done so. Advancing your use of commands by providing flag switches and where you can go to learn about these. For each command, man pages, some more commands that you will frequently be using to interact with the file system and its contents. Yes. A brief introduction to file permissions and switching users. Yes. A summary paragraph of the important root directories on a Ubuntu Linux install and how, or Ubuntu, whatever you call it, and how we may be able to use the data stored within these. So one particular directory is /tmp temp, where we can write all sort of data and any user can write data into it. Okay, I encourage you to go through this room again once or twice to gain some familiarity with the concepts. We have already done so. We are confident we are done enough, at least myself. But if you think that you need to remember the commands, then you can try all the commands that I have taught you in this room once or twice, and you will be done for next lesson. You will be ready for the next lesson. Proceed to the next task to continue your learning. Continue. Okay, so visit the part 3 for the Linux Fundamental series here. Terminate the machine for the task 2. Let's do that. Join the Linux Fundamental part 3. We will also do that once we complete this. As you can see, there is no ticketing at all. Thank you guys for joining me on this journey. We have completed this room. If you like this video, please give it a thumbs up. If you have any question, please put it in the comment section down below. And if you haven't subscribed, please subscribe to the channel. Help us build the community and let's learn together. And once we come back, we will start the Linux Fundamental part 3. And thank you for joining me, and I will see you in the next video. Bye bye.